Hey guys, I hope you're ready for Unit 2, which is Astronomy. Now, I know that you just completed the demo looking at the different sizes of the planets within our solar system, but I did want to show you this picture just to again re-emphasize, look at just how small the Earth is compared to the Sun. The Earth is so tiny there, and yet you can barely even fit the Sun in this picture. But what really is mind-blowing to me is this next picture. Down here you have the Sun, and the Sun is even smaller than the Earth is compared to the Sun, compared to these giant stars. But then look at this giant star down here compared to what we call super giant stars. It's absolutely amazing to me how we think the Sun is so large, but in reality, compared to other stars in our universe, the Sun's actually a very small star. This always just blows my mind to think and brings into perspective just how small we are compared to the whole universe. And I always like to show students that before we start the astronomy unit. So what is astronomy? Hopefully you already remember this from Unit 1. And if you do remember this from Unit 1, then there's no need to write this down. Astronomy is simply the study of space. It's a science that deals with the universe. And so what we're going to look at in this very short astronomy unit is different laws and theories that all have to deal with space and how that impacts the Earth. So let's continue on. Okay, the first thing we're going to look at are a couple of laws. These are known as Kepler's laws, and Kepler, who was around a really long time ago, 1571 to 1630, which you do not need to remember, he came up with 3 laws, and he had very, very plain, boring names for them. He was not creative at all, even though he was extremely smart. His first law is called Kepler's first law. His second law, Kepler's second law, and his third law, Kepler's third law. Although he kept the names very simple, it does make it hard sometimes to remember which is which, and you will need to know that for the test. So I could ask you a question and just say, I could read out the law and say, which law is this? Kepler's first, second, third, or his fourth. And hopefully you don't pick the fourth one. So you will need to remember that his first law is the orbits of planets are an ellipse, and the second law, which goes to which. So just make sure that you do make note of that when you study. So I always remember it because his first law is the easiest law to understand. The orbits of a planet is an ellipse. Remember, if you are orbiting the sun, that means you are going around the sun. So as the Earth goes around the sun, it goes in an ellipse-shaped or an elliptical shape, which is simply an oval. And all an oval looks like is a squished circle. So everything that is orbiting the sun or anything else is going in an oval shape, not a circular shape. And so that's pretty easy to understand. So that's why I think his first law, like a level 1, the most simple to understand. So first law, the planet's orbit is an oval or an ellipse. His second law is a little bit more complicated or a little bit harder to understand, but it's not too bad. His second law simply states that a line between the sun and a planet sweeps equal area in equal times. So I want you to pause this video in just a second, and based on what the second law is saying, I want you to think about how that applies to this diagram. So how does this second law apply to this diagram down here? And so I want you to decide within your table groups, is the Earth going to move faster from point 1 to 2, 4 to 5, 6 to 7, 8 to 9, 10 to 11, or whatever? So between which two numbers do you think the Earth is going to move the fastest? So go ahead and discuss it with your table groups and pause this video. If you said that the Earth was going to move the fastest from from space 1 to 2 or from 12 to 1, then you are correct. So good job. Go ahead and give yourself a pat on the back. But I do want to go ahead and explain why this is. So this is simply saying that each of these triangles, this triangle, this one, this one, this one, this one, this one, all of them, they all have the same area. So if you knew how to find the area of a triangle, you could do that for all of these and they would all have the same area. Because of what his second law says, that means that the Earth is going to have to move each distance in the same amount of time. So think about if you had to run from point 7 to 8, and you ran from point 7 to point 8 in 30 seconds, then that means that you're also going to have to run from point 1 to 2 in 30 seconds. But notice how much longer this is over here. So if you're going to do that in 30 seconds, you're going to have to be running pretty dang fast. So to get from 1 to 2 or from 12 to 1, you're going to have to make cover that same distance in the same amount of time. So therefore, the Earth is going to move fastest, closest to the sun, and it's going to move the slowest when it's further away. And not just the Earth, this goes for all planets. So planets move faster when they're close to the sun and slower when they're further away from the sun. And to help you remember this, I do have something for you to watch. I don't know if any of you have ever watched figure skating or know anything about dancing, but I do have a pretty cool video to show you, and then I will explain to you how it will help you remember this law. So you can go ahead and pause this video and then play the ice skater video. Okay, I hope you enjoyed the ice skater video. And I just want you to think every time that you think of Kepler's second law, that the Earth is going to move fast close to the sun. So just like this ice skater over here has her arms close to her, if you put your arms crossed in like that, that's when the Earth is moving fast. So her arms are close, so close means fast. If her arms are far away from each other, like they are in this picture, then that means slow. So you can literally do this to help you, maybe not on the test days, but you can do this to help you remember his second law. The planets move fast when they're close, just like when the ice skater's arms are fast. And the planets move slow when they're far from the sun, just like the ice skater has her arms out far like that. So his first law, simplest to understand, planets just go in an oval or an ellipse shape. Second law, the planets go fast when they're close to the sun, and they move slower when they're further from the sun. So that's not too complicated, but that's a little bit harder, which that's why it's his second law. His third law is the most complicated to understand, but don't worry, it's not going to be too bad. His third law states that a planet's orbital period squared is equal to its average solar distance cubed. You do not need to know the formula down here, okay? So don't worry about remembering that. I just wanted to show it to you. We aren't going to do anything with that math. So a planet's orbital period. An orbital period is talking about the time it takes for it to get the planet to get around the sun. If you take that time for it to go completely around the sun and you square that number, so just square it, so however long that takes, then that's going to be proportionate to its solar distance cubed. So how far away it is from the sun at that time, if you take that value and cube it, it's a proportion. The way I remember this is if you ever see any weird math thing on a test, that's his third law, okay? The third law is the weird math thing. Whether that is an actual formula that you see or it's just talking about his orbital period squared and something else cubed, if you're just reading something that sounds like a lot of math, think, oh, that's Kepler's weird third law, because we're not going to do anything else with that, okay? You are very welcome. If you go on to take other astronomy classes, then maybe you'll get into that. Okay, so first law is the oval, easy to understand. Second law, fast when it's close, slow when it's far from the sun. Third law, weird math thing. And if you need to pause the video at any point to finish writing, you are welcome to, but I'm going to move on. So those are the first three laws of astronomy. Now we are going to take a brain break, so that will give you time to finish up writing. If you should see a feather in the middle of your desk. So if everybody will get a feather, then your brain break is simply to toss the feather up, catch it, and be as creative as possible. Maybe stand up, catch it, spin around, try to catch it, or toss it up, kick your leg over it, but don't kick anybody else, and try to catch it. Just get up, get moving, and try to catch a feather. And no, You may not keep the feathers at the end of the brain break. I will need them back. But go ahead and enjoy. Okay, hopefully you are good and awake now. Now that we've looked at 3 laws, we're just going to look at a couple of theories. And the best theory to start with, the Big Bang Theory. So this is how the entire universe started. Now, I want you to pay very close attention to universe. I know I didn't bold this, but you should write this down. The Big Bang Theory is how the universe started. It is not how the Earth started or the solar system, it's how the universe began. It's not only a good TV show, but it's an actual theory. So within the Big Bang Theory, all that it's talking about is everything that's ever existed and will exist was all at one time confined to a very dense, hot, supermass ball that exploded. And the reason why it says hot here is because you can think of energy as heat. So all of the energy that exists, it was all within that supermass ball. So that's why it was so hot, because it had so much energy. That ball exploded. And now think about, if something explodes, it's going to go outward. So you had everything condensed to a teeny, tiny little dot. And then for some reason, that everything just exploded, and out came the entire universe. And so that was 13.7 billion years ago. And if you just want to write that as 13.7 BYA billion years ago, you can do that to abbreviate. So the Big Bang Theory, it was the universe that began. A very dense, hot, supermass ball exploded, and that was about 13.7 billion years ago. You do need to be familiar with about how long ago it was. They're not going to give you answer choices that say stuff like 13 or 13.5, 13.7, and make you choose between those. But they may give you something in the millions versus the billions, so you do need to be familiar with about how long ago it all occurred. So that was our first theory, how everything started, and our next theory we'll look at after the Big Bang Theory happened, what then caused the planets in the solar system to occur. So let's go ahead and go to our next theory. This is called the nebula theory. Everybody say nebula. Nebula is simply saying how the bodies of our solar system evolved. Now, if you think about this, what are the bodies of our solar systems? Well, the bodies of our solar systems are planets and stars. We have the sun in the center of our solar system, and that's a star, and then we have planets going around that. So when it says the bodies of our solar systems, this is the same thing as if you're saying it's how all stars evolved and how all planets evolved. And so what this theory is telling you is that there were these giant nebulas, and there still are nebulas around now. And these bottom pictures are all pictures of nebulas, which I think are really pretty. This one right down here I think is cool because it looks like an eyeball. You could add some little eyelashes to it. And I just think it's neat. So anyway, those are some pictures of nebulas. They're very pretty. But all they are is a cloud of dust and gas. And the two main gases within these nebulas are hydrogen and helium. And do be familiar with H for hydrogen and HE for helium. I know you've looked some at chemistry in middle school, but a lot of times they do just put the abbreviations on the test and not the full word. So with the nebula theory, you just had this giant rotating cloud of gas and dust, and that made our planets, and that also made our stars. So based on this, what I could do is ask you something like, what two gases are in a star? Well, you should know hydrogen and helium because stars came from a nebula, and that's what's in a nebula. So make sure you are familiar with that, and you can apply it to different forms of questions. We have one more theory to look at, and we'll go ahead and move on to that. Our next theory is the expanding universe theory, and this is probably the easiest one to remember because it's simply saying that the universe is expanding. Okay, the expanding universe theory, universe is expanding. You pretty much don't even need to write anything else down but the name. Very self-explanatory. But the reason why we know the universe is expanding is because the space between the galaxies is getting bigger and bigger and bigger. So we know that different galaxies are spreading out more and more. And because of that, that must mean that the universe is getting larger. So because the space between galaxies is expanding, that means therefore the universe is expanding. Okay. Once you get this down, we're about to pause the video. So if you need to get it from a neighbor, you can. But what I want you to do is, once the video is paused, I want you to try to put these in order from smallest to largest. You can just do this somewhere on the side of your notes, and then we will go over it and make sure that everybody has the right size. So go ahead and pause the video and put them in order from smallest to largest. Okay, so let's go ahead and look at the answers. So the smallest one is going to be first the moon. So the moon is the smallest, followed by the earth. After the earth is going to be the sun. After the sun is going to be the solar system. The solar system is in the Milky Way, and everything is then in the universe. So hopefully you got those all right. I always like to go over this just to make sure we're all in agreement of what's smallest, what's largest. Sometimes that's something that is assumed that you remember from middle school or elementary school, but you may not because it's been so long since you've looked at it. So smallest was the moon, then the earth, then the sun, solar system, Milky Way galaxy, and the very last thing or largest thing is the universe. So now let's review. Make sure that you understand everything. So you should have your Plickers papers on your desk. So we are just going to take a little quiz on the different laws and make sure that you remember everything. So go ahead and pause this video and go ahead and take your quiz. Good luck.